All right, so we have this block, let's see, a block of mass m sliding down an inclined plane with a constant speed. Constant speed, that means acceleration. The acceleration equals 0 at an angle theta with respect to the horizontal. Use this diagram for questions 14 through 18. All right, so the first thing that we need to do is set up our axes here, so we can see that that this mass will be sliding down the inclined plane in that direction. So that's the orientation that we need to set up for our axes. So let's do that first. So let's set up the axes. So we're going to have something like this, and something, this would be our x-axis. All right, and then let's put in our forces while we're here. Let's do that in a different color. So we have its weight, and its weight will be going straight down. So that would be mg. And then we also have its normal force, which normal force is perpendicular to the surface that it's on. So this would be normal force. And always remember that we come off of this y-axis for theta. All right, so number 14, what's the x component of the gravitational force? So the x component, would be this portion right here. So this would be all right, so let's look at this. Let's move this mg and put it over here because that is that side. So we have, we're looking for this component right here. And that side is the opposite of the angle. So opposite, and we have the hypotenuse. What relates those is sine theta equals opposite over hypotenuse. In this case, sine theta equals opposite over mg. So the opposite side will be equal to mg sine theta. So mg sine theta would be our best bet. For number 15, the y component of the gravitational force, well, the y component, we're looking for this portion, which is the adjacent side. So the adjacent side would be mg cosine theta. Okay. Number 16, what's the normal force applied to the block? Well, we can see that the normal force up here is going to be equal to the y component of the gravitational force, and the y component of the gravitational force was mg cosine theta. So 16 would be mg cosine theta. What's the kinetic friction force acting on the block? Well, we know that kinetic friction force is equal to mu k Fn, and we just said that Fn was equal to mg cosine theta. So we're looking for mu k mg cosine theta. All right, so for number 18, which of the following is true about the coefficient of kinetic friction? All right, so we need to put in here our force of friction, which is opposing forward movement. Let's make some room here. So let's sum up the forces in the x and y direction, but let's do the y direction first. So the summation of forces in the y direction equals mass times acceleration, but this object is not going to go up and down in a y direction, so that's going to be 0. So we have Fn going up minus mg cosine theta equals 0. So Fn equals mg cosine theta. Now in the x direction, we have the summation of forces equals mass times acceleration. And again, they said that it's moving at a constant speed, so acceleration is 0 up here. So we have our force of friction in a positive direction minus mg sine theta is going to equal 0. Our force of friction is mu k mg minus mg sine theta equals 0. Mu k mg equals mg sine theta. Divide by mg on both sides, we have mu k equals, oh, I lost something here. Let's go back. I lost mg sine theta. So we have mu k mg cosine theta. Mg cosine theta minus mg sine theta equals 0. We can divide by mg on both sides, and we have mu k cosine theta minus sine theta equals 0, or mu k cosine theta equals sine theta. Mu k equals sine theta over cosine theta. Sine over cosine, mu k equals tan theta. So that's mu k is tan theta, C.